Today we're going to take a closer look at arithmetic and geometric sequences. We talked briefly about these yesterday with the recursive, but today we're going to just take a closer look at these two. So, first thing I'm going to do here is I'm going to write down quite a few sequences. So the first one, 2, 8, 14, and 20. The second one, 3, -6, 12. The third one, 11, 4, -3, -10. And that should be the fourth one, 81, 27, 9. And all of these are just going to go on forever. So first thing I'm going to ask us to do is identify whether these are arithmetic or geometric. So if we look at this one, 2 to 8, we're adding 6. So if you guys remember, if we're adding or subtracting, this one is arithmetic. 3, -6, -12, we're multiplying by -2. So this one is geometric. Let's see, 11 to 4, 4 to -3, subtracting 7, so it's arithmetic. 81 to 27 to 9, it's going down. And if we're ever unsure how much, we can just take any term and divide it by the previous if we recognize that it's geometric. So 27 divided by 81 is 1/3. And you get the same thing if we would have chosen another one. We could have done 9 divided by the previous of 27. I don't know why I wrote 1/2 here. That is 1/3. So this one is geometric. Now, on all of these, let's say I was to say find the 10th term. Well, let's see. If I was to look at the arithmetic one, to find the 10th term, I start at 2, and I'm adding 6, but to get the 10th term, how many times do we really have to add 6? Because to get to the second term, I add it once, twice, 3 times, so it's 1 less than the term, so times 10 minus 1. So it'd be 2 plus 6 times 9. So we have 56. So let's see if that works for the other geometric one. We start at 11, and we're subtracting 7. And again, we have to subtract it 1 less than the term we want, so 10 minus 1. So we have 11 minus 7 times 9. So 11 minus 63. We'd have -52. Now geometric, to get that 10th term on a geometric, we start at 3, but we're multiplying, and it's still 1 less than the term we want, so 10 minus 1. So this would definitely be a calculator one here. So 3 times -2 to the power of 10 minus 1. Oops. Guess I gotta put that. So we have -1536. And then let's see this one. We start at 81. We're multiplying 1/3, 10 minus 1 times. See, I got some extra parentheses here. So we have 0.004. Yeah, that gets small pretty quickly. So if we were to summarize this, if we needed to write any term here, the nth term, we have a different way to find it for arithmetic and geometric. So arithmetic, to find any term, we start with the first term, and then we add our difference n minus 1 times. So this stands for our first term. D stands for our difference. And n is our term number. Whereas for geometric, to get a term number, we start with our first term, but we're multiplying by that ratio to the power of n minus 1. So we have here, once again, first term, and that's our ratio right there, what we're multiplying by. And now we're going to take a look at a couple here that aren't just number sequences. We might have some that have some algebra in it. So the first term, 1, 5x minus 9, 9x minus 15, 13x minus 21. And let's say you need to find the 10th term. So let's take a look. We got x's and numbers. So what's changing in our x's? 5 to 9, we're adding 4x. 9x to 13x, we're adding 4x. And then what changes with just the numbers? 9 to negative 15, we're going down 6 and down 6. So I tend to rearrange this, what's going on with our x's and our numbers. So our x's, we start at 5x. Plus, we want our 10th term, so 10 minus 1 times, we're going to add 4x. So we start at 5x plus 9 times 4x. So let's see, that's 5x plus 36x. So we have 41 x's there. Where our number, we start at negative 9 plus 10 minus 1 times negative 6. So we have negative 9 plus 9 times negative 6. Negative 9 minus 54. So we have negative 63. So our term would be 41x minus 63. So let's take a look at another one with x's, because those are a little trickier. So let's say we have negative 4x cubed, negative 12x to the 8th, negative 36x to the 13th. So again, let's see what's happening here. We got numbers. And it looks like our number is times negative 3. And then if we look at our exponent, we're adding 5. And let's say you want to find the 6th term. So we have a numbers and then the x's. So our number, it's geometric because we're multiplying by negative 3. So negative 4 times negative 3 to the 6 minus 1. So let's see, negative 4 times negative 3. 6 minus 1 is 5, so we have 972. And our x's, we start at 3, and we're adding 5. So 6 minus 1, we have to add it 5 times. So this would be 3 plus 25 is 28. So it would be 972 x to the 28th. Now, we're going to take a look at just a couple more here to see how we can figure out some other stuff. So let's see, say in an arithmetic sequence, the 9th term, u sub 9, is 48, and u sub 12 is 75. And you have to write out the formula for the nth term. So we have to fill in those blanks here. What we're filling in is a sub n, a sub 1, plus n minus 1 times d. So we got to figure out our first term and our difference. Well, we're given the 9th term and the 12th term. So in 3 terms, how far is it from 48 to 75? So 75 minus 48, it's changing by 27. So what does that mean our difference is? So 27 in 3 terms, so our difference is 9. So we know that our difference here is 9. We don't know our first term, and we don't know the nth term. But our goal is to find that first term, and we know what the 9th term is the 12th, so we could substitute one of those in. We could say 48 is our first term. We don't know, but we know 48 is our 9th term. So we know 48 equals a sub 1 plus 8 times 9. So 48 equals a sub 1 plus 72. So minus 72 minus 72. 48 minus 72 is negative 24. So a sub 1 equals negative 24. So we have then everything we need. A sub n, negative 24, plus n minus 1 times 9. And we could double check. That should work for if we were to plug in 12. We should get 75. So we could say, that didn't work for some reason. Uh-oh, what happened here? Let's try again. So we could say negative 24 plus our 12th term times 9. That gave us 75, so it's good to go. So let's see what this would look like if we looked at one that was geometric. So, in a geometric, let's say the second term equals negative 6 and the 5th term equals 162. And again, we have to find that nth term. Well, for one like this, I like to make a table. So we know that this is negative 6 and 162. And we know we're multiplying times a common ratio. So if we start at negative 6 times r cubed, we end up with 162. Well, let's solve for r. Divide by negative 6. So we have negative 27. So r cubed equals negative 27. So what number cubed gives you negative 7? R would be negative 3. So if r is negative 3, we know something times negative 3 gives us negative 6, so that would be 2. So we have our formula, because we know it's our first term times our ratio to the n minus 1. So a sub n equals 2 times negative 3 to the n minus 1.